Naming alkenes and alkynes. Recall that alkenes have a double bond and alkynes have a triple bond. The carbon chain must include the multiple bond. We want to use the ending "ene" if there's a double bond, or "-ine" if there's a triple bond, as appropriate. You want to number the chain carbons so that you get to the multiple bond as soon as possible. The multiple bond takes precedence over any other substituent or any branching. Multiple bonds wear the pants. Use di or tri right before the "ene" or "-ine if you have 2 or 3 multiple bonds. We have the name here, so let's draw the structure of this molecule. The prefix "but" indicates we have 4 carbons. The "-ine" suggests we have a triple bond, and the 1 shows that the triple bond starts at carbon number 1, like I've shown here. 1, 2, 3, 4 carbons. The triple bond starts at carbon number 1 and connects it to carbon number 2, and that's the carbon backbone. If we were to put hydrogens on there, where they would fit, there would be 1 that's attached to carbon number 1, 0 that are attached to carbon number 2, 2 of them attached to carbon number 3, and 3 hydrogens attached to carbon number 4 for a total of 6. In the next one, we're given the structure and we need to name this. So let's count the carbons in the chain. 1, 2, 3, 4. This is going to be butene. Again, we have a triple bond. So this is also going to be butene, but this one's going to be called 2-butene. And that's because the triple bond starts at carbon number 2, and in fact, no matter which end you start numbering from, the triple bond starts at carbon number 2. If we're counting hydrogens here, we're going to find 3 at each end and no hydrogens at carbons 2 or 3, so this one also will be C4H6. How about this last one? Here we need to number so that we get to a multiple bond as quickly as we can, which clearly means that the one on the left here is carbon number 1. So we have 1, 2, 3, 4, 5, 6, 7, and then where do we go? Well, now we need to make the longest chain 8, 9. This is going to have the prefix "known" in it for 9. This will be enes because we have double bonds, and it will be diene because we have 2 double bonds. This molecule's name is going to end with nonadiene. Now we need to say what carbon the double bonds start with. So that's going to be carbon number 2 right there. There's carbon number 3. There's carbon number 4. 2,4-nonadiene. That naming right there takes care of everything from the left all the way to the upper right. And the only thing we haven't mentioned is this methyl group right here, which is connected to carbon number 7. So I'm expecting 7-methyl to pop up, and there it is. If we were to count atoms, we'd count 10 carbons and 18 hydrogens. This molecule ends with 3-octyne, so let's draw 8 carbons in a chain with the triple bond indicated by the "-ine between carbon number 3 and carbon number 4. So there's your 3-octyne right there. Then off of carbon number 7 we have a fluoro substituent, and off of carbon number 6 a methyl substituent. Recall that we put them in that order because fluoro comes before methyl alphabetically. If we were to count atoms here, we would count the 8 carbons in the main chain plus the 9th one from the methyl. So we have 9 carbons, 1 fluorine, and let's count the hydrogens, 15. How about this last one? In a previous lesson we talked about Cyclo Alkanes. Well, this clearly is a cyclo alkene, particularly cyclohexene, because there are 6 carbons in the complete circle. We always number the carbons such that the multiple bond is gotten to as quickly as possible, which means that either this is carbon number 1 in the lower right, or this one on the right is carbon number 1. Now, whichever one we choose as carbon number 1, carbon number 2 has to be the other one. In other words, if this one in the lower right is chosen as carbon number 1, then this one here has to be carbon number 2, because the multiple bond has to start at the lower numbered carbon and go to the higher numbered carbon. In other words, we couldn't start at this carbon on the right and call it carbon number 1 and then proceed counterclockwise. Oh, here's carbon number 2, carbon number 3, carbon number 4. On the far left, you can't do that. The multiple bond has to go from the lower numbered carbon to the higher numbered carbon. Do we want the lower right corner to be carbon number 1, or do we want the one on the right to be carbon number 1? We want these trichloros to have the lowest numbers that they can. Let's just guess and check. If we number the lower right carbon as carbon number 1, that would be 1, 2, 3, and 4. So the chloros would go 3, 3, 4. If we number carbon number 1 as the one on the right and go clockwise, then this would be carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and we would go 5, 6, 6. Well, those numbers are way bigger than 3, 4. So, the one in the lower right is carbon number 1, the one on the right is carbon number 2, counterclockwise around that ring. For geometric isomers, different spatial arrangements of atoms use cis, which means same, and trans, which means opposite. Geometric isomerism is possible only with alkenes. Here we have 6 carbons in a chain. Now, it's not drawn the way we have typically been doing it, but you can see 6 carbons in a chain, and there's a double bond here, so this is going to be hexene. And no matter which end of the chain we start with, we're going to have the double bond starting at carbon number 3 and going to number 4, so we call this 3-hexene. And now we have to take into account these chloro substituents. So we have carbon number 1, 2, 3. There's a chloro attached to carbon number 3 and a chloro attached to carbon number 4. So we say 3,4-dichloro. And then, are these chloros on the same or opposite sides? And they are on opposite sides. So the name of this compound is 3,4-dichloro-trans-3-hexene. The one at the bottom is very similar. We again have 6 carbons in a chain with a double bond between carbons 3 and 4. So this is again 3-hexene. We have chloro substituents hanging off of carbons 3 and 4, so this is 3,4-dichloro, but now you can see that those chloro substituents are on the same side, so we say cis.